soos ons groei in kundigheid, mag U ons lei. Sien ons hoe hier, lei met U hand, laat U seamless oor ons land. Three strong streams united flow, Africa stands proud and tall. As we learn, we trust, we know God is in control. Bless us, O Lord, guide us with grace. May Northwest be blessed always. Bless us, O Lord, sien ons hier. Oor is Jehovah se morena, sien ons, bless us, O Lord.
Goeiemiddag sê liewe broers, susters, baie dankie dat u hier is, teenwoordig is. So my 'n vreugde, voorreg en 'n eer om die opening vir u waar te neem. A single verse from scripture, from Proverbs chapter 18 verse 15. 'n Mens met insig doen kennis op. Wyse mense hou hulle ore oop vir kennis. Let us pray. Father God in heaven, thank you for the privilege of being teachers. Thank you for the students you entrusted to us. Thank you for the institution where we can serve. Thank you for your guiding presence as we fulfill our vocation. Here God, as ons vanaand spesiaal en spesifiek vir Carina bid, skenk aan haar die wysheid om haar tyd so te bestuur dat sy goed voorbereid voor klasse sal staan, met mense in gesprek sal tree. Skenk aan haar genade om misplaaste skuldgevoelens agter te laat, want ek kan doeteenvoudig nie alles vir almal doen nie. Grant me discerning eyes, O Lord, that I may see my students as you see them, that I may love them as you love, that I may anticipate potential mental blocks, that I may discover the key to unlock their desire to learn. Help ons Here dat ons met ons vooropgesteldhede nooit in ons studente se pad sal staan nie. Melt their resistance to what is good and right and true. Melt their fear of failure. Melt their overwhelming pride. Melt the distractions that vie for their attention. Here, en soos wat ons met ons studente omgaan, laat ons iets van U na hulle toeskyn. Wanneer ons werk kritiseer, laat ons dit doen met grasie en met liefde. As ons leiding en rigting gee, wil ons fyn ingestel wees op U leiding, op die influistering van U Heilige Gees. Here, wanneer ons nuwe konsepte voorstel, maak ons woorde helder en verstaanbaar. O Lord, let me discover anew the joy of learning and let my joy be contagious. Let me be the first to surrender my ill-informed opinions to the light of your presence, where they may be transformed by truth. Let my blind spots be exposed so that I do not mislead others. May my institution be stronger because I am here. May I build up my colleagues rather than exalting myself. May I be willing to serve even without recognition. As ons vanaand bid vir Carina, Here, as ons U smeek om haar te bederf met krag en wysheid en insig en kennis en liefde en vrede en vreugde en hoop, dan moet ons dankie sê vir pappas en mammas, vir vriende, vriendinne, vir kollegas. Maar dan moet ons ook dankie sê vir Hannes, en vir Derek en vir Melanie, vir liefde en steun. O Lord, may you receive all the glory. And this we pray in Jesus' name. Amen.
Goeienaand, dames en here, good evening, ladies and gentlemen. I am Avi Kotse, Executive Dean of the Faculty of Health Sciences, and it's really an honor and a privilege to do the welcoming at this inauguration ceremony of Prof. Carina Mels of the Faculty of Health Sciences at the Noordwes-universiteit. A special word of welcome to Prof. Jeffrey Palele, our Deputy Vice Chancellor for Research and Innovation at the Noordwes-universiteit, who is also our main functionary for this evening. It's really an honor, Prof. Jeffrey, to have you here with us, and we are looking forward to your continued support, loyalty, dedication, and friendship to this faculty and its staff members. Baie dankie en baie welkom dan ook aan Dominee Vanus Hansen, wat vir ons geopen het met gepaste skriflesing en gebed, en ons hoop dat u die aand ook saam met ons sal geniet. Welcome also to other members of the University Management Committee and Senior Management Committee, which might be in attendance or who will follow the ceremony afterwards by virtual access. I also welcome members of the Faculty Management Committee of the Faculty of Health Sciences and of the Noordwes-Universiteit directors and officials. First of all, I must say that we have kept it small due to COVID regulations. 2 weeks ago we've got one, and after that one a couple of staff and people attending have been tested positive, so we've kept this really small. First of all, Prof. Sanet Brits, she's the Director of Physiology, Nutrition and Consumer Sciences. That's a school which is associated with a research entity or Center of Excellence, Heart, from which Carina is the Director. Prof. Marius Smits, and he's part of a Precision, and he's the Director of a Center of Excellence for Nutrition in the Faculty of Health Sciences. Then specific apologies, you will see there are chairs that open. It's Professor Johan du Plessis, which is the Director for Occupational Hygiene and Health Research Initiative. He's in isolation. The same with Prof. Rosa, he's the Director of a DST or DSI, Northwest University Preclinical Drug Development Platform in the Faculty of Health Sciences. And then it's really a privilege to also welcome Prof. Marlene Pieters, who is the Director of a Medical Research Council Extramural Research Unit for Hypertension and Cardiovascular Disease, also situated in the faculty. And then really an honor to welcome our colleagues from the Faculty of Natural and Agricultural Sciences. First of all, Prof. François van Westhuizen, sitting at the point of a nice colorful gown there, who's the Deputy Dean, Research and Innovation in the Faculty of Natural and Agricultural Sciences. Prof. Ruan Lau, and I have to see where is Prof. Ruan sitting next to him. Yeah, the light is in my eyes. Prof. Ruan Lau, who's the Research Director in the focus area for human metabolomics, also in the Faculty of Natural and Agricultural Sciences. And then Prof. Sarina Klaasen. There is Prof. Sarina. Prof. Sarina Klaasen, Director for the School of Biological Sciences, also in the Faculty of Natural and agricultural sciences. So I think you can guess where the roots of Carina is lying. It was, of course, in biochemistry and in natural sciences, so, but they couldn't keep her there. She found a nicer faculty to come and work. Sorry, Francois, for that one. So we've stolen her and she's very happy with us. She said she will never go away there. A special word of welcome also to the staff members, I'm just joking, to the staff members of the Center of Excellence for Hypertension in Africa Research Team. This is HART, a short acronym. This is the center in which Prof. Carina works and of which she's a director, and all her colleagues and collaborators. In particular, also a word of welcome to all the postgraduate students which might be present here and other staff members of the university. 'n Spesiale woord van verwelkoming dan ook aan Prof. Carina se familie en vriende wat vanaand hier is. Haar eggenote Mels, haar dogter Melanie, ek moet nou eers kyk, waar is dit Melanie? Melanie het maar vir jou 'n nuwe rok gekoop. Het sy? Ek maak net seker, da. En dan haar seun Derrick het klaar vir my buite gesê hy het 'n nuwe hemp gekry. Anders het ons vanaand vir ma gestuur om môre daai inkopies te gaan doen. En dan nog met 1% by ook. Dan spesifiek ook haar ouers, ons is bly dat haar ouers saam met ons kan wees, Karel en Susie Maree, haar skoonma Judy Mels en haar swaar Frikkie Mels. Ook 'n spesiale woord van verwelkoming aan haar afgetrede kollegas, en hulle lyk vir my al hoe jonger elke keer as ek hulle sien. Prof. Hugo Huisman, wat die vorige direkteur was van HART, en Hugo, ek het nie vir Magda hier gesien vanaand nie. Sy is by die huis, en dan reglangs Prof. Hugo, daar sit Prof. Johannes van Rooyen, wat nog steeds ook 'n kollega is wat afgetree het 'n hele klompie jare terug, maar nog steeds aktief is as ons noem dit 'n post-65 aanstelling in HART. It gives me now great pleasure, ladies and gentlemen, to introduce to you a very special lady, our special guest of the evening, Prof. Carina Mels, and I request that she join me for introducing her to you. And this is very special for me also, because if I remember correctly, Carina, both your promotions to associate professor and professor was handled by myself. So it's always so nice to see that somebody who has been promoted to associate professor quickly go through the ranks and don't stagnate, and they do their part. Now for the formal part. Carina Mels, born on the 9th of December 1981, grew up and matriculated at high school Transvalia in Vanderbijlpark. After completion of her undergraduate studies, that was a BEc in Biological Sciences in 2002, and that was still, I think, at the former Potchefstroom University for Higher Education, now Noordwes-universiteit. She continued with postgraduate studies and obtained the BEc Honours in 2004, an MSc in 2006, and a PhD in 2011. All in the subject field biochemistry from the Noordwes-universiteit. After completion of her PhD, she accepted a position as subject specialist at the Hypertension in Africa Research Team HART at the Noordwes-universiteit. Since her appointment in HART, she was promoted on the following dates: 2011 Senior Subject Specialist, 2012 Senior Lecturer, 2016 Associate Professor, and 2020 Full Professor. Currently, she is also the Research Director of HART. In 2016, she received a Y2 rating from the National Research Foundation, the NRF, indicating that she has the potential to establish herself as a researcher within 5 years after obtaining her PhD. At the beginning of 2021, she applied for re-rating, and we are eagerly awaiting the outcome of her application, and we are sure that this will be a good rating that she will receive. She established various collaborations with international cardiovascular experts at highly ranked universities such as the Institute of Cardiovascular and Medical Sciences of the University of Glasgow and the University Medical Center Hamburg-Eppendorf in Germany. She also managed to obtain more than 7 million rand to fund various aspects of research, including Noordwes-university funding, but that's normally small amounts, to improve a heart research laboratory and her own development as a researcher, as well as funding from national bodies such as the nwu-pukke program, 2012 to 2014, the Medical Research Council, the MRC in the Self-Initiated Research Program, 2015 to 2017, and the South African Sugar Association, SASA, 2017 to 2018. Since 2011, she published 78 papers. And listen now carefully, all in international peer-reviewed ISI journals. So it means nothing nationally, all international and in ISI journals. And that is exceptional to have this amount of papers at this young age already. She has supervised 20 honors students, 13 masters and 7 PhD students. On 2 occasions, her students received the Vice Chancellor's Medal for Most Outstanding Master's Degree Students in the Faculty of Health Sciences. Currently, she is supervising 7 masters and PhD students. She is also the principal investigator of the African Prospective Study. We know it as the African Predict Study, on the early detection and identification of cardiovascular disease and hypertension, as well as a prospective effect of COVID-19 on early cardiovascular disease development in Africans. That's a new study that you will hear a lot from in the future, the Precede Africa study, which has started in 2021. And this is so nice for me to see that our researchers are reacting to the recent and to the relevant topics that is currently on the table around the world. She is frequently invited to deliver plenary and keynote presentations at both local and international conferences. Based on these outputs, she also received recognition for her research, including presentation awards from the American Society of Hypertension and South Africa Hypertension Society and the South African Stroke Society. As a member of the International Society of Hypertension since 2013, several future pieces on her research were published, and in 2020 she was elected to serve on the Africa Regional Advisory Group of the International Society of Hypertension. She is also frequently invited to review papers for journals such as Journal of Hypertension and funding agencies such as the NRF and the UK Medical Research Council. She also serves on the editorial board of the journal Metabolomics. Locally, she was selected in 2018 to serve on the board of directors of the Southern African Hypertension Society, as well as the next generation committee of the society. You will all agree with me, ladies and gentlemen, that this is truly a remarkable academic record and an excellent achievement for such a young person. And I won't mention her age. If you were listening carefully at the beginning, you could do your calculations, but this is really exceptional. And with this, ladies and gentlemen, we will now proceed to hand over the academic ware to Prof. Carina and invite her to deliver her inaugural lecture of the title Oxidative Stress and Hypertension, a Balancing Act. Congratulations from my side, Carina, and enjoy your presentation, and we are looking forward to a lot of new heights in your career. Congratulations.
Dear Deputy Vice-Chancellor for Research and Innovation, Executive Dean for the Faculty of Health Sciences, Deputy Dean for Research and Innovation in the Faculty of Natural and Agricultural Sciences, Research Directors, School Directors, respected fellow professors, colleagues, former and current students, family and friends. It is my honor to welcome you at my inaugural lecture entitled Oxidative Stress and Hypertension, a Balancing Act. What is balance? As a noun, balance is an even distribution of weight, enabling someone or something to remain upright and steady. Or it is a situation in which different elements are equal or in the correct proportions. That sounds easy enough. But why do we keep on getting it wrong? In our everyday life, we fight constantly to maintain balance between work, our lives, our families, and our health. While we are struggling on the outside to maintain what is known as work-life balance, the human body is facing its own internal challenges to maintain homeostasis. In this regard, the human body is in constant chemical communication with the external environment. When we eat, nutrients are absorbed through the inner lining of the digestive tract. When we breathe, gases such as oxygen, carbon dioxide move across the epithelium of the lungs, and waste products are continuously being excreted. Even though these processes occur at various specialized sites in the human body, they affect each and every organ, tissue, and cell instantaneously due to the fact that all the parts of the human body are linked to the cardiovascular system. To gain a complete understanding of the cardiovascular system, you must start at the heart of it all, the cardiac cycle. The cardiac cycle can be determined as a period between two heartbeats and include periods of contraction and relaxation. At the start of the cardiac cycle, known as ventricular diastole, the ventricles, or the bottom chambers of the heart, are filled with blood. At the end of this phase, the atria, or the top chambers of the heart, will contract to complete ventricular filling. This will then be followed by ventricular systole. Then the ventricles will start to contract, and the arteriolar valves, that is the valves between the atria and the ventricles, will close. This will lead to an increase in pressure in the ventricles and consequently the opening of the pulmonary valves. When these valves open, blood is forced out of the ventricles and into the aorta and the pulmonary arteries, from where the blood will be distributed to all parts of the human body. Thereafter, the ventricles will start to relax and the pressure inside them will drop, and the aortic and pulmonary valves will shut again until a new cardiac cycle commences. This brings us to the concept of blood pressure. So during the cardiac cycle, pressure in the arteries will also fluctuate, increasing during ventricular systole and decreasing during ventricular diastole. Systolic blood pressure is therefore the highest blood pressure measured during systole, and diastolic blood pressure the lowest blood pressure measured at the end of diastole. In the reporting of blood pressure, this will be reported as two separate values, such as 120/80 millimeters of mercury. In addition to the contribution of the cardiac cycle to blood pressure, peripheral resistance also plays an important role. And to maintain blood flow, the pressure within the circulation must be great enough to overcome resistance to flow, and that is the resistance provided by the entire cardiovascular system, and that is known as peripheral resistance. Total peripheral resistance is a function of vascular resistance, viscosity of blood, and turbulence. Viscosity is determined by the amount of cells, such as red blood cells or white blood cells or platelets, present in the blood. And an increase in viscosity will lead to an increase in the resistance to flow, while turbulence is caused by high flow rates or irregular surfaces due to injury in a blood vessel. Vascular resistance, on the other hand, is determined by friction between the blood and the vessel wall, where the amount of friction will depend on the length and the diameter of the vessel. Since the length of a blood vessel cannot be changed, vascular resistance is determined by changes in the diameter of a blood vessel, and this happens via contraction and relaxation of smooth muscle cells within the vessel walls. So, given this very important role of the cardiovascular system, it is no surprise that blood pressure is tightly regulated. When the balance or the homeostasis in the human body is disturbed, the cardiovascular system must adapt very quickly to ensure adequate blood flow to the tissue or the organ where the change occurred. The cardiovascular system therefore engages in resource allocation. For example, when you exercise, your muscles, the heart, and the lungs will have a higher demand for blood flow. But following a meal, the demand for blood flow will shift towards the digestive system. So, various mechanisms are therefore employed to regulate blood pressure. Autoregulation is the main mode of regulation under normal resting conditions, when cardiac output remains stable and entail adjusting of peripheral resistance. So upon alterations in the local environment, such as changes in oxygen or carbon dioxide levels, the smooth muscle cells will respond automatically to these changes in the local environment, and they will respond via the release of either a vasodilator, such as nitric oxide, or a vasoconstrictor, such as endothelin-1. But when autoregulation becomes ineffective, a neural response will be triggered, where the nervous system will act via two receptor reflexes. The baroreceptors are responsible to detect changes in pressure, and the chemoreceptors changes in oxygen, carbon dioxide, and pH levels. And stimulation of these reflexes will result in the adjustment of both cardiac output and peripheral resistance to maintain adequate blood flow. Endocrine mechanisms relies on the release of hormones such as epinephrine and norepinephrine, which will result in short-term changes in both cardiac output and peripheral resistance, while long-term changes will rely on the release of other hormones, including the renin-angiotensin-aldosterone system, to control blood volume, sodium levels, and red blood cell production. So, although the mechanisms of blood pressure regulation are universal to mankind, some ethnic disparities, which occur most likely due to external factors such as rapid urbanization, are in fact evident. In a study done in China, it was projected that the incidence of heart attacks and stroke will double in urban areas. It was also indicated that rural to urban migration may lead to increases in blood pressure, where systolic blood pressure was 6 to 7 millimeters of mercury higher in urban migrants when compared to their rural counterparts. Bringing this back to sub-Saharan Africa, it is very interesting to note that less than 100 years ago, it was nearly impossible to find a single patient with hypertension in a hospital in Kenya. However, with the recent demographic transition on the African continent, adverse health behaviors are expected to escalate, with strong trends already evident. Africa also experiences some of the world's greatest economic, educational, and health inequalities, which may also contribute significantly to this problem. In some of our own work by my colleague, Professor Kafane Matemane et al., we provided a detailed profile of the renin-angiotensin-aldosterone system, electrolytes, volume loading, blood pressure, and total peripheral resistance in a young and healthy population consisting of black and white adults. And in this population, we found that plasma renin activity in the healthy black adults was almost half of what we observed in their white counterparts. Longitudinal associations between aortic blood pressure and the renin-angiotensin-aldosterone system revealed that an increase in aortic blood pressure over 4.5 years was associated with elevated aldosterone levels. Again, this was only evident in the black population. In fact, we also observed that blood pressure measured over a 24-hour period during the day and during the nighttime were also higher in black and white men and women when compared to their white counterparts. And this may be associated with a phenomenon we call early vascular aging. So early vascular aging reflects an increase in arterial stiffness. So that is when the arteries get stiff at a younger chronological age. And in a recent review paper, ethnic disparities in routine blood pressure measures, the development of hypertension, and cardiovascular outcomes were further investigated in the context of early vascular aging. And in many studies, comparing arterial stiffness between ethnic groups over the life course, including children as young as 6 years of age, ethnic disparities were found, where populations from African descent presented with increased aortic stiffness from younger ages. So other mechanisms, such as the balance between factors associated with autoregulation of blood pressure, may further explain the ethnic disparities noted, and that was the focus of my research to date. So the concept of change in the diameter of blood vessels via contraction and relaxation of the smooth muscle cells are closely related to endothelial function, where nitric oxide and endothelin-1 are natural counterparts in this equation, and tipping the balance between vasodilation and vasoconstriction may lead to endothelial dysfunction. So under normal conditions, the bioavailability of the vasodilator nitric oxide will be high, and this will lead to the inhibition of endothelin-1 synthesis and reduced binding of this molecule to its receptor, and consequently all downstream effects such as vasoconstriction will be inhibited. However, with a reduced bioavailability of nitric oxide, endothelin-1 activities will not be inhibited, and it will be and increased vasoconstriction and vascular remodeling may be the result thereof. So in the vasculature, nitric oxide, and you should get used to that word, I'm going to mention that one many times tonight, but nitric oxide is produced from the amino acid L-arginine, or its structural homologue, homoarginine. And this is done in a reaction that is catalyzed by the enzyme endothelial nitric oxide synthase. And after its synthesis, nitric oxide can diffuse from the endothelial cell into the smooth muscle cell. This will lead to the production of cyclic guanosine monophosphate via the activity of guanyl cyclase. That will lead to a reduction in calcium influx and release into the smooth muscle cells in a process that is dependent on protein kinases, and that will eventually lead to vasorelaxation. So that will make the cell to relax. So the bioavailability of nitric oxide is therefore very important. and the balance and is determined by the balance between its synthesis and its breakdown. So the balance between how much you make and how much you use or how much is inactivated. The synthesis of nitric oxide is therefore influenced by the availability and the transportation of its main substrates, namely L-arginine and homoarginine. Now, arginine is a semi-essential amino acid and can be synthesized within the human body in case of dietary insufficiency. And although L-arginine deficiency is rare, it may occur with increased L-arginine metabolism via the enzyme arginase in the urea cycle. Transportation of L-arginine into the endothelial cells occur via enzyme transporter, or rather an amino acid transporter, namely CAT1. However, there is a molecule with the name symmetric dimethyl arginine, or in short, SDMA, and that may lower L-arginine uptake as it competes with arginine for transportation, and that will indirectly affect nitric oxide synthesis. Another very similar molecule, ATMA, or asymmetric dimethyl arginine, may also impact on nitric oxide synthesis, as that is a competitive inhibitor of the NOS enzyme. Alternatively, nitric oxide can also has a high affinity for superoxide, that is a reactive oxygen species, and I will get into that a bit later. And binding of these two molecules will lead to the formation of peroxynitrite, and that will make nitric oxide inactive and not available to perform its function. Furthermore, nitric oxide can also undergo metabolism to nitrate and nitrate, which may serve as a nitric oxide store, as it can be reduced back to nitric oxide via several different pathways. So I think the concept will of nitric oxide bioavailability and how it is determined by a balance between different factors is sinking in with you now. And the decrease in the bioavailability of nitric oxide may impact on the vasculature through various different pathways. It may lead to the development of atherosclerosis, and that is characterized by thickening of the arterial wall, or it may lead to vascular stiffening or stiffening of the arteries. So apart from its role in vasodilation, nitric oxide also plays a role in several inhibitory actions, so it hinders things to take place. And that is quite prominent to maintain healthy endothelial function and prevent the onset of atherosclerosis and arterial stiffness. So I think atherosclerosis is a concept that many of you may have heard before, and that is the term we use for the process of plaque build-up in the inner lining of an artery. And with the buildup of plaque, the wall of the vessel will thicken, and consequently the lumen of the vessel will be narrower, and thereby the flow of blood through the vessel will reduce. This is a slow and lifelong process, but it may already start in childhood, and it will get worse as you age. The process of atherosclerosis can be measured by means of ultrasound, where we measure the thickness of the intima media layer of the carotid arterial wall, and that gives us an indication of plaque formation. As mentioned, the bioavailability of nitric oxide may also impact on the stiffness of arteries. With the contraction of the heart, a pulse wave is generated which travels through the arterial tree. When you are still young, your aorta is still very much elastic, and the pulse wave will take a much longer time to travel through the arterial tree. But with aging, the aorta and other arteries in the body will lose their elastic properties, and the pulse wave will travel much faster through the arterial tree. And this may lead to increased pressure in the aorta, which will have a negative impact on your heart and other organs, and we call that target organ damage. So the time it takes for the pulse wave to travel between two sites in the arterial tree, which is known as pulse wave velocity, can be measured non-invasively to give us an indication of how stiff your arteries are. So when keeping the various blood pressure regulation mechanisms in mind, it is no surprise that many factors may contribute to the development of hypertension. And the multifactorial nature of hypertension was first described in 1940 by Dr. Irvin Page when he developed the mosaic theory of hypertension. This theory proposed that multiple factors, including genetics, environmental factors, anatomic, adaptive, neural, endocrine, humoral, and hemodynamic forces, all contribute to the development of hypertension. Since then, vast progress was made to explain the molecular and cellular basis of hypertension, and the discovery of nitric oxide by 3 Nobel Prize-winning scientists in 1998 made a huge contribution in this regard. Later, in 2013, upon revisiting the mosaic theory, Dr. David Harrison explained that all of the same concepts or all of the same things that determine hypertension is also involved in oxidative stress. And later on, in 2020, very recently actually, Dr. Rian Tewis published a review paper in which oxidative stress was portrayed as a unifying paradigm in hypertension. Okay, so if oxidative stress is then at the center of hypertension development, I guess it's important to know what is oxidative stress. So according to the textbook definition, oxidative stress is an imbalance between oxidants and antioxidants in favor of the oxidants, and that will lead to a disruption in redox signaling. Now, redox signaling is when a message gets conveyed through your body from one part to another. It may also lead to a loss of control in these systems and eventually to molecular damage. Okay, so that's the definition, but what is oxidants and what is antioxidants then? So all atoms contain electrons in spaces known as orbitals, and normally these electrons are present in pairs. However, some molecules, known as free radicals, have an unpaired electron, rendering these molecules unstable and very unhappy. And to regain stability, free radicals have the habit of stealing electrons from other molecules. Antioxidants, on the other hand, are very generous molecules, and they are willing to donate all their spare electrons. So, if free radicals are so bad, where does they come from? Various normal physiological processes are in fact involved in the production of free radicals, and these free radicals are known as reactive oxygen species, or ROS, and I won't bore you to go into details of this picture tonight. But fortunately, the production of ROS in the human body is balanced by its own endogenous antioxidant enzyme system. This system firstly consists of the enzyme superoxide dismutase, and this enzyme is responsible for the binding of superoxide anions with an electron, leading to the formation of hydrogen peroxide. Hydrogen peroxide can then be reduced to water and oxygen via the action of 2 enzymes, namely catalase and glutathione peroxidase. In the reaction catalyzed by glutathione peroxidase, glutathione will be oxidized. And luckily, the body also has another enzyme known as glutathione reductase, and this enzyme can take the oxidized or glutathione disulfide molecule and reduce it back to its original form so that the body can use it again. So, to assess the balancing act between oxidative stress and hypertension, it is very important to not only include elderly populations or populations with advanced disease, but to rather investigate the interplay between these factors over the life course. Therefore, findings from data in children as young as 6 to 8 years old, young adults between 20 and 30 years, and older adults will be discussed. Firstly, in the arterial stiffness in offspring study, or ASOS, this is a cross-sectional observational study aimed to investigate tendencies of high blood pressure, arterial stiffness, and body composition in 6 to 8-year-old black and white school children. The African Predict study is a longitudinal study with the central aim to follow young between the ages of 20 and 30 years and apparently healthy black and white adults over the course of 10 years. And when looking back, hopefully we can identify novel markers related to early cardiovascular disease development. We will also be looking at data from the SABA study, the Sympathetic Activity and Ambulatory Blood Pressure Monitoring in African study. And this study is a psychophysiological prospective cohort study which was conducted in 409 black and white school teachers. And the aim of this study was to investigate the brain-heart link and neural response pathways to describe possible mechanisms for cardiometabolic disease. Lastly, I will also be discussing data from the PURE study, or the Prospective Urban and Rural Epidemiology study. This is an international study of which the South African leg was conducted in the Northwest province of South Africa, and this study aimed to track changes in lifestyle and cardiovascular disease risk factors over the course of 10 years in black participants. So again, maintaining endothelial function is dependent on the balance between nitric oxide synthesis and inactivation, where oxidative stress plays a very important role. So, low nitric oxide bioavailability in early life, when you're still a child or a young adult, may therefore be a predisposition for the early development of cardiovascular disease. And perhaps it may in part explain some of the ethnic disparities previously noted. So in this study, we indicated that in black children as young as 6 to 8 years old and the young adults, that they had lower nitric oxide metabolites. We also found higher NOS substrate, L-arginine, but that was along with higher ATMA levels, which is the inhibitor for nitric oxide synthesis, suggesting that there is an overall unfavorable nitric oxide bioavailability profile. So upon further investigations into how this profile would link to various cardiovascular markers, we found that lower nitric oxide markers, that is the metabolites and the substrate, are associated with higher blood pressure and other cardiovascular markers such as carotid intima media thickness. And this was found only in young black children and young black adults. In the SABA cohort with older adults and some having blood pressure levels in the hypertensive ranges, we found, strangely enough, overall more favorable nitric oxide synthesis profile, as evidenced by the higher substrate, both arginine and homoarginine levels, and lower nitric oxide inhibitor levels, both ATMA and SDMA. So that is quite strange when you compare that to the young children and the young adults where we did not see this profile. But in context of the higher oxidative stress profile, the seemingly more favorable nitric oxide synthesis capacity may be counteracted by increased nitric oxide inactivation. And in fact, we indicated that lower glutathione peroxidase activity, that is the one enzyme that helps with rendering free radicals inactive, we found that that was associated with higher ATMA levels, the inhibitor for nitric oxide synthesis. So it is well known that modifiable risk factors, such as physical activity, can also affect the vasculature, and this may happen via mechanisms that is associated with nitric oxide bioavailability. We therefore investigated the link between these factors in physically active and physically inactive groups. And despite them only reaching moderate physical activity levels, we found in the physically active group that the arteries were more compliant and that the homoarginine levels, which is the substrate to produce nitric oxide, were higher. In the physically inactive group, we found that 24-hour blood pressure was associated with higher SDMA levels, the nitric oxide inhibitor. So our findings suggest that even moderate physical activity levels may have beneficial effects on the nitric oxide profile, and this may mitigate the development of cardiovascular disease. So in the PURE study, we investigated if baseline nitric oxide markers were associated with blood pressure levels after 10 years, and we investigated this in patients that remained normotensive or that developed hypertension over this time. At baseline and at follow-up, they had similar homoarginine levels, but we found protective associations between nitric oxide, the nitric oxide substrate homoarginine, and various blood pressure measurements. And we found this only in the group that remained normotensive over this time. And the fact that these factors was not linked in the hypertensive group may suggest that once hypertension develops, other factors may surpass the protective effects of homoarginine. When we investigated this nitric oxide profile in relation to carotid wall thickening, we found that lower homoarginine, remember that's the substrate for nitric oxide synthesis, was associated with a thicker intima media thickness over 5 years. Again, supporting the role that homoarginine may play a protective role against vascular injury. The potential protective effects of homoarginine were further supported when we investigated whether homoarginine levels are associated with 10-year risk for all-cause and cardiovascular mortality. And interestingly enough, we found that homoarginine levels in non-survivors were higher than in the non-survivors. And in fact, we also found that higher homoarginine levels are associated with a reduced risk for 10-year cardiovascular and all-cause mortality. So that is death due to any reason or death due to cardiovascular-related reasons. So to summarize these findings related to ethnic disparities in nitric oxide bioavailability, we found in Black children and young adults that lower nitric oxide bioavailability may contribute to the development of hypertension in later life. This may happen via mechanisms associated with endothelial function, atherosclerosis, and arterial stiffness. Findings in older populations indicated that maintaining optimal homoarginine levels may protect against the development of hypertension, atherosclerosis, and even mortality. However, when even with a favorable nitric oxide synthesis profile, the availability of or the presence of oxidative stress may lead to inactivation. And this underlines the importance of lifestyle modifications, such as engaging in moderate physical activity levels to maintain the balance between these role players. So just a few findings on what we found regarding the oxidative stress profile. So when reflecting back on the mosaic theory, it is quite striking that all the cardiovascular risk factors, such as smoking, high cholesterol, a family history, aging, high blood pressure, all of these factors are also associated with oxidative stress. So, since family history may impact on the development of cardiovascular disease, we investigated the link between oxidative stress and vascular function in young boys based on their maternal cardiovascular risk. And only in children with maternal risk, we found higher blood pressure and arterial stiffness, and this was associated with markers of oxidative damage to both lipids and DNA. These findings therefore support the link between a family history and the early onset of cardiovascular disease, and this link may be modulated by oxidative stress. We also investigated the link between oxidative stress and other mechanisms associated with peripheral resistance, such as hemostasis, that is the blood clotting profile, and endothelin-1 levels, which is responsible for vasoconstriction. Previous work indicated that the black group had an altered hemostatic and oxidative stress profile, but it was unclear whether these components function independently or whether they were in fact related. And we found that lower glutathione peroxidase activity are associated with higher levels of von Willebrand factor, and that is a marker of endothelial dysfunction. And we also found that this antioxidant enzyme was related to an increased clot lysis time, and that is the time it takes for a blood clot to be broken down. Regarding endothelin-1 levels, the levels were found to be similar when comparing black and white groups, but very unique associations were found with markers of oxidative stress. And these findings therefore suggest that there is in fact an interrelationship between oxidative stress and different mechanisms associated with peripheral resistance. So in one of the very first oxidative stress-related papers, and this was even before I joined the Hypertension in Africa research team, it was shown that lower glutathione levels are associated with an increase in carotid intima media thickness in hypertensive black men. And this finding suggested that lower glutathione levels may lead to the development of atherosclerosis. But as you all know now, glutathione levels are determined by various factors, and therefore we decided to do a more comprehensive oxidative stress profile. In black compared to white groups, we found higher serum peroxide levels, higher catalase activity, lower glutathione peroxidase activity, a higher glutathione reductase level, and also a higher ratio between the two. And these findings suggest that the balance is shifted more towards the oxidative state. Additionally, we also found that lower glutathione peroxidase activity was associated with higher blood pressure. And that was in black women, while in black men, glutathione reductase activity was associated with an increase in carotid intima media thickness. With the above-mentioned findings limited to the SABA cohort, which is older individuals with some already in the hypertensive ranges, their blood pressure that is, it remained unclear whether these findings were confounded by those factors, and therefore we aim to profile oxidative stress markers in a young population of the African PREDICT study. And our findings were very similar, with higher total glutathione levels, but lower glutathione peroxidase activity and total antioxidant status. We also found that the lower glutathione peroxidase activity was associated with pulse pressure over a 24-hour period. Again, this findings is related to the black population. So from the previous findings, it became quite evident that the lower glutathione peroxidase activity may be a weak link in the enzymatic antioxidant system. And we therefore investigated the availability of selenium, a very important cofactor for this enzyme. So a cofactor is kind of, you need a friend to help you to do the job. we found that 1 in 10 black men and 1 in 5 black women were selenium deficient. However, we were unable to link the lower selenium or glutathione peroxidase activity to blood pressure in the black group. But interestingly, in the white group, we found that higher selenium levels and higher glutathione peroxidase activity was protectively associated with blood pressure and arterial stiffness. And these findings suggest that lower serum selenium levels in black populations that lived in the same geographical region as the white counterparts may impact on the loss of the vascular protective effects of both selenium and selenoproteins, such as glutathione peroxidase. Again, it was unclear whether the findings in the SABA cohort was confounded by age and blood pressure, and we therefore tried to replicate our findings in the African PREDICT study. Here we found that only 2% of the total African PREDICT cohort was selenium deficient, and both markers of the micro and the macro circulation was associated with serum selenium and glutathione peroxidase, and this was evident in both the black and white groups, confirming the vascular protective role for selenium and glutathione peroxidase, and interestingly enough, confirming that when you have sufficient selenium levels, you may have sufficient action of this enzyme, because we saw only 2% selenium deficiency in this group, and the associations were evident in both the black and the white groups. So in the PURE study, we investigated long-term associations between selenium and atherosclerosis, arterial stiffness, and hypertension. In a group with normal selenium levels, we found long-term vascular protective associations of selenium on arterial stiffness, blood pressure, supporting the notion that selenium has vascular protective effects. However, in the highest quartile of selenium levels, a potential detrimental association between selenium and carotid wall thickness was identified. Again, these findings highlight the importance of balancing selenium levels as well. So, the constant balancing act to maintain a healthy redox state and hence a healthy cardiovascular system also became evident in the application of novel omics technologies. So, omics can be defined as a large amount of data representing an entire set of some kind. For example, an entire set of molecules such as proteins or lipids or metabolites. Different types of omics will thus provide a holistic view. For example, genomics provides an overview of the complete set of genetic instructions provided by the DNA, while transcriptomics investigate gene expression patterns. In proteomics, dynamic protein products and their interactions are studied, while interactions between the genetic makeup and the environment can be studied with metabolomics. So even when we followed this very holistic approach, it still came down to balancing of various factors, including oxidative stress. In this regard, we used metabolomics to assess the early molecular determinants of arterial stiffness, and metabolomics analysis revealed more abundant levels of several non-essential amino acids, and these amino acids were inversely related to central blood pressure. And again, we only found this in the black group of the study. And since central blood pressure may also impact on the heart and lead to hypertrophy of the left ventricular wall, we also investigated the link between this metabolomics profile and left ventricular mass index. And we found that 2 of the same metabolites or amino acids were also associated with left ventricular mass. So since these amino acids play a pivotal role in maintaining collagen biosynthesis, And this is also a process with oxidative stress at the center. Our findings suggest that the biosynthesis of these non-essential amino acids may be upregulated to protect the cardiovascular system against early deterioration. In our latest research, we used metabolomics to profile cardiovascular risk factors, including obesity, physical activity, smoking, excessive alcohol intake, hypertension, high blood sugar, high cholesterol values, and also a low socioeconomic status. And we also clustered some of these cardiovascular risk factors together, and we then compared them to a control group without any cardiovascular disease risk factors. And when we did that, and we compared the metabolomics profile between these groups, we saw that a hyperglycemic state, that is high sugar levels, were the most significant in terms of differences between various amino acids. That was followed by a low socioeconomic status and obesity. So in these risk groups and also in the risk clusters, we identified 3 affected metabolic pathways. And again, the involvement of oxidative stress was quite prominent. So, our findings related to cardiovascular disease risk factors and oxidative stress clearly support the link of oxidative stress with factors of the mosaic theory. We demonstrated a link between maternal risk and the early onset of cardiovascular disease, and that this may be modulated by oxidative stress. Environmental factors such as diet and balanced levels of micronutrients such as selenium, which is an important role player in the optimal functioning of the antioxidant system, was linked to vascular protection. Regarding anatomical, adaptive, and hemodynamic factors, we linked oxidative stress to blood pressure, to compliance of the arteries, to peripheral resistance, to arterial stiffness, to carotid intima media thickness, cross-sectional wall area, and microvascular calibers. And we also linked oxidative stress to factors determining peripheral resistance, such as nitric oxide, endothelin-1, and hemostatic markers. And even when following a very holistic approach, such as metabolomics, the involvement of oxidative stress was identified as a prominent feature related to cardiovascular disease risk. Several of the factors included in the mosaic theory remains to be investigated, so at least I don't have to pack my bags and go find another job. So with such a prominent role of oxidative stress in the development of hypertension, one has to think in terms of antioxidant therapies, and that has in fact been the focus of multiple studies. In fact, various studies in animal models provided encouraging findings, but as soon as those findings are translated to human disease, it is rarely successful. And in my opinion, it is due to the fact that hypertension is a multifactorial disease. And I believe that the individualized approach, taking all of these factors in consideration, would be much more effective than a one-size-fits-all approach. However, when considering the context of the sub-Saharan Africa with economic, educational, and health inequalities, perhaps the focus should be at health education to tackle those modifiable risk factors such as diet and physical activity. Now, of course, none of this would mean anything if it was not balanced by giving back to the community and having an impact there. The statistics related to hypertension is always an eye-opener. Hypertension is the #1 contributing risk factor for global death, and more than 10 million lives are lost each year needlessly due to raised blood pressure. And what is even worse is the fact that only half of the people with high blood pressure know that they have the condition. We therefore take pride in our involvement in the awareness campaign of the International Society of Hypertension, known as May Measurement Month. And this is just a few pictures of the fun we have at these events, where we go out and measure blood pressure to create awareness. Another very important aspect is science communication as a further step to create awareness, and in this regard, we are also quite active. And of course, I could never have done this without the help of many, many special people in my life. This morning I came across the following on a Facebook post. The people we surround ourselves with either raise or lower our standards. They either help us to become the best version of ourselves, or they encourage us to become lesser versions of ourselves. We become like our friends. No man becomes great on his own, and no woman becomes great on her own. The people around them help them to be great. We all need people in our lives to raise our standards, to remind us of our central purpose, and to challenge us to become the best versions of ourselves. And tonight, I want to thank all the people in my life who made this possible. Starting with family. My man Hannes en my kinders Derek en Melanie. Dankie dat julle my elke dag uitdaag om die beste moontlike weergawe van myself te wees. Soms sukkel ek regtig met hierdie work-life balance ding, veral in die laaste tyd ter voorbereiding vir vanaand. Maar gelukkig het ek vir julle om my te help met daai balans. My seun Derek was seker so 5 of 6 jaar oud toe hy eendag vir my vra: "Mamma, weet jou baas en daai mense by jou werk dan nie dat jy kinders het nie?" Hy was nog altyd die een wat gehou het van praat. En dan my jongste Melanie, wat alles in die lewe met oorgawe aanpak en vir niks bang is nie. En dankie ook dat jy gedink het mamma se speech is nie boring nie. Still with family. Om 'n loopbaan in die akademie te kan hê en die alledaagse gesinsdinge nog steeds te kan juggle, sou nie moontlik gewees het sonder die ongelooflike ondersteuningsnetwerk wat ek het nie. As ek moet reis na kongresse, is dit nie 'n probleem nie. As ek skielik die kinders nie by die skool kan gaan kry nie, is dit nie 'n probleem nie. En daarvoor wil ek vandag dankie sê vir my ouers en my skoonouers, en veral ook my oorlede skoonpa wat altyd in my geglo het. Then my awesome colleagues there at the back. Vandag wil ek eerstens dankie sê vir die mense wat nie meer deel is van die span nie, want hulle het ons gedra tot waar ons vanaand is. Prof Alta Skutte, Prof Rudolf Skutte, Prof Nico en Leonie Milan, Prof Hugo Huisman, wat ook hier is vanaand, dankie Prof. Prof Johannes van Rooyen, wat ook hier is vanaand, dankie Prof. En Prof Carla Fourie. En dankie ook Prof Johannes en Prof Carla dat julle my gehelp het met die proeflees van die intrerede. Tweedens wil ek dankie sê vir my jong kollegas, en hier gaan ek net een persoon vanaand uitsonder, want julle is almal uniek, en julle almal bring julle eie unieke sterkpunte na die groep toe, en dit maak ons onstuitbaar. Baie dankie vir julle almal se ondersteuning, en baie dankie Adrian vir al jou hulp met die slides. Then colleagues from other entities, Prof Roan Lou. So Roan, ek en jy loop nou al 'n lang paadjie saam van my biochemie daar, en nog steeds fight ons nie te veel nie, so ek dink ons is op 'n goeie pad. Dankie vir die ondersteuning wat jy my bied, en dankie dat jy my intrek in hierdie exciting omics wêreld. Ek sou dit nie sonder jou kon doen nie. Prof Fransjo van der Westhuizen. Nou ja, toe ek op 'n stadium op 'n kruispunt in my lewe was, waar ek moes besluit het, bly ek by biochemie of gaan ek hart toe, het hy vir my die lig laat sien. Hy het vir my gesê, Carina, hierdie is 'n geleentheid wat jy nie kan laat gaan nie. So Prof Awie, hy het my eintlik aangemoedig. Dan Piet, ja, dankie vir al die lang ure langs die massa spektrometer. Sonder 'n PhD sou daar nie vanaand 'n intrerede kon wees nie, en ek is baie van daai PhD te danke aan jou. Prof Piet Pretorius in sy afwesigheid. Prof Piet Pretorius was my promotor in my PhD-studies, en dit is in sy tweedejaars klas, molekulêre biologie, waar ek die heel eerste keer van omics geleer het. Prof Lardus Erasmus was ook 'n promotor van my, ook in sy afwesigheid. Baie dankie vir al Prof se insette. Prof Marlene Pieters, ek weet ons paadjie het onlangs eers regtig gekruis, maar baie dankie dat ek op jou knoppie kan druk en met jou idees kan bons en ek is seker volgende jaar gaan ons Kaaptrippie baie vrugte afwerp. Dan the faculty management team, Prof Avi Kotse en Prof Janetta Du Plessis in her absence. Prof Avi en Prof Janetta, baie dankie vir die ondersteuning wat ek van julle kant af ook kry, veral in die bestuur. Dit is regtig 'n gerusstellende gevoel om te weet, julle staan agter my en julle het my rug as enigiets sou verkeerd loop. Prof Sanet Brits, baie dankie Prof Sanet, dat ek en jy saam hierdie hartspan kan lei en dankie vir jou ondersteuning wat ek vandag een af gehad het, ek waardeer dit. Prof Marius Smits en Prof Johan Du Plessis in sy afwesigheid. Hierdie is my 2 direkteure, my go-to people, as ek enige vrae het. Baie dankie dat ek altyd op julle knoppie kan druk en dat julle my altyd in die regte rigting wys. Dan natuurlik my nagraadse studente. Sonder hulle sou niks hiervan moontlik gewees het nie. These pictures are not of all the students, but those whose work I presented this evening. Thank you for granting me the permission to show your photos. And some of you are also here tonight. Yolandi, Anya, and Cleo. Thank you for coming, and thank you for choosing me to take you on your postgraduate journeys. Then a huge thank you to my collaborators, and 2 in particular, and Prof Avi already mentioned them earlier. The first one I want to thank is Prof Edzard Swetalem from Germany. He made huge in-kind contributions to my research by analyzing all the nitric oxide-related markers free of charge. He was also the host to my former PhD student, Cleo, who spent some time in Germany during her PhD studies. Without his support, many of the findings presented here tonight would not have been possible. And then the second very meaningful collaboration I want to highlight and thank is Prof Christian Dellis from the University of Glasgow. On 2 occasions, Prof Christian hosted me at the University of Glasgow, and during these research visits, he really opened his network to me, and that made a huge difference in my career. Thank you for all the messages that I received. I'm just putting them up here because I want to be reminded of them when I look back on this presentation. And then, of course, research is expensive. We won't be able to do any of this without our funders, and you can see all of them there on the screen. Then lastly, a very special thank you to Prof Jeffrey. Thank you for being here tonight, Prof. I know that you have a hectic schedule. I really appreciate your presence here tonight. Dominee Vanus, baie dankie vir die ongelooflike gebed. Ek het myself in soveel aspekte raak gesien. Ek waardeer Dominee se teenwoordigheid hier vanaand. En dan nog een persoon, Bianca Petersen, en ek weet nie of dit appropriate is om nou 'n bos blomme aan haar te oorhandig, nie? Thank you all.
Just to finish off, ladies and gentlemen, I promise I won't keep you too long. Our inaugurant and the VIP for today, Professor Carina Mels, and Prof. Mels' guests, represented here by her family, friends and colleagues from all over the globe, because we also have people who are going to watch this online, and the members of the Faculty of Health Sciences, represented by the students. I'm glad to hear that there are students here, and staff, directors, deputy deans, and the executive dean, Prof. Avi Kotse. And also to extend this to Other faculties present, especially Faculty of Natural and Agricultural Sciences, represented here by Professor Francois van der Westhuizen. As I always say, goeienaand. On Friday evening, so good evening and dumelang. I hope we can have a light moment because this is the last one for the year, Prof. Avi. So we don't have to be too academic, but it gives me a great pleasure indeed to deliver a congratulatory message and present a certificate to Prof. Mels on this special day of her inauguration into professorship. I congratulate you, Prof. Mels, on this joyful yet a landmark moment for you and your loved ones, for your colleagues at Northwest University, and for your collaborators in South Africa and elsewhere. In fact, something that we have in common is that I also had, collaboration with the University of Glasgow. I spent 2 years in Glasgow, Conrad Dumbarton and Church Street. That was Institute of Virology there. So I was quite thrilled to see that you had, and maybe you still have, the collaboration with University of Glasgow. Well, as it was said in ancient Greece, inaugurations were at times pompous, but mostly dignified and well-meaning, and serving as the opportunity for the formal investiture of a person into a position of authority. And so today is that day, Prof. Mels, that marks the rite of passage and the entry into the distinguished community of university's most senior academics, the professors. Your inaugural lecture bears testimony to lifetime scholarly achievements that culminated in you being a full professor. And when I say lifetime, I know that you told us you're not packing your bags yet. So there are still a lot of research questions that you would like to pursue, and good luck with it. I listened attentively with interest as you artfully and masterly presented your topic on oxidative stress and hypertension, a balancing act. I am pleased to see great things you have accomplished in your career, young age, even though we are not allowed to reveal the age. But this is really impressive. Well done, and keep up the great work. So if I was a youngster, I would say, you rock. And maybe if there is anything to take home about your presentation, is the pictures of the elephants balancing on the balloons. I don't know how they do that, but it looks like they can do it. If that is not just art, it's real. So it's really sending a powerful message on the topic that you shared with us. The interaction of oxidative stress and hypertension. But just promise me one thing, and I'm not going to ask you to tell me in public. You can tell me when we are taking a drink maybe. If I decide to be naughty from time to time, as I always do, with my beers and my chili wors, I hope taking supplementary tablets of selenium will solve the problem. I don't need to worry about exercise. And I'm saying this because I'm a member of Virgin Active. You know what? For the first year, I was very loyal and behaving. But second year, I then started copying what the naughty people are doing. walk in, swipe your card, walk out. So I'm doing that occasionally, but if selenium tablets can solve my problem, not maybe partially solve my problem, just let me know. Just whisper in my ears. So from your presentation, Prof. Mels, the audience will agree that it was a riveting, informative, and thought-provoking presentation and illuminating. However, as I previously said in another occasion, these are not moments for just a mere recognition and celebration of scientific excellence. They are the moments very much about celebrating the impact we make through science. It is the scientific impact that is a game changer. While we adore the scientific excellence in the form of, publications in prestigious journals, and we encourage that, but actually is the impact these publications make in changing our lives, which is really, really a game changer. I am encouraged by the fact that you are still with us, and we look forward to your further groundbreaking work in your discipline and within your research group, Hypertension in Africa research team. So good luck with further work, and I'm sure you'll still do a lot of exciting work. On behalf of the Northwest University, I am proud to present to you a certificate of achievement. As professor tonight, I am confident that your future academic exploits will continue to benefit your students, the research community, and the world at large. So warmest congratulations, Prof. Mels. Welcome to the ranks of professor. And most importantly, I hope you will enjoy every privilege and prestige associated with these ranks. Well done, and thank you. Token of appreciation. Well done.
Oh Thank